Okay, in this video, we are going to talk about polymers. Okay, so polymers. Polymers are large macromolecules. So it's really hard to draw them here. So we need to shorten them. I'll give an example. Let's talk about polyvinyl chloride, or PVC in short. Okay, so polyvinyl chloride looks something like this. Okay, so we have carbon. Okay, carbon, carbon is repeated. Every other carbon has a chlorine bound to it. Okay, and so forth. Now, then we can complete the structure by adding the carbon hydrogen bonds. Okay, if you want to make it a complete Lewis structure, then you need to add the lone pairs as well, which is too much actually. Okay, so instead of drawing the polymer molecule like this is PVC, by the way. Okay, polymer molecule like this, what we can do is we can draw the line structure of the polymer. So we know that ends and bends are carbon atoms. So let me draw them. So this is my 1, 2, 3, 4, 5, 6, 7. Okay, I have drawn only 7. Okay, it goes on like that. But anyway, so instead of drawing the Lewis structure of a polymer, what we can do is we can draw the line structure, which is much more convenient. So here's my carbon 1, which is an end. Okay, and then this is my second carbon. The second carbon, you have a chlorine bound, and then that is bound to the third carbon. The fourth carbon, you have a chlorine bound, and then goes on like that. Okay, so it goes on like that. So this is the line structure of the same polymer. You can see that it's much easier to draw rather than drawing all the atoms. Now, now this is the polymer. Okay, this is what we call the polymer chain or polymer chain. To the entire molecule, entire polymer molecule. Now, instead of drawing the entire polymer molecule, what we could do is we can draw what is repeated. Okay, we call this the polymer structural formula. So to do that, what we do is we first try to understand what is repeated. Okay, you can see that there's carbon, so carbon chlorine bond and another carbon is repeated over and over here. So for example, this part is repeated over and over and over. Okay, so instead of drawing the entire polymer molecule like this, what we could do is we can take out what is repeated and draw that. Here's what is repeated. Okay, so if I label the carbons, okay, here's my 1, here's my 2, here's my 1, here's my 2. Okay, according to what I drew here, you can see that the first carbon I have chlorine bound, and then I have the second carbon. Okay, so this is repeated over and over in the polymer. So what we do is we draw parentheses around it. Okay, and then we're going to write a subscript n to indicate that this unit is repeated n times. Okay, so this n can range from 50 to thousands or 10,000s. Okay, but what matters is it's a large number. All right, and then to indicate that this repeat unit is connected to other units around it, we're going to draw these bonds coming out of that, like that. Okay, this is called the polymer structural formula. Right, that this is the polymer structural formula, or it's like the shorthand notation for the polymer chain. Okay, Now, the next thing is the monomer. The polymers are made of monomers, and monomers polymerize to give us the polymers. So if somebody asks you, what is the monomer of this polymer? What we need to do is we need to take out the repeat unit. So we know that what is repeated here is this 1 and these 2 carbons here. Okay, 1 and 2. When you get that, this is 1, this is 2. Okay, and then we're going to draw chlorine because that is repeated as well. Okay, now instead of drawing 2 bonds coming out of 1 and 2 first and second carbon, okay, what we do in the monomer is we draw a double bond between those two atoms, and that is called the monomer is polymer. Okay, now what we did was we dealt with PVC here. So just to appreciate that, okay, we can write this is PVC or polyvinyl chloride. That is what we used in pipes in plumbing. Okay, so let's do another one. Okay, let's do something. Ethylene, polyethylene. Okay, that's what we use to make plastic bags. So polyethylene polymer looks something like this. Okay, we call this PE, polyethylene. So it just goes like that. Okay, I'm just drawing the line structure here. Okay, so again, when it comes to determining the repeat, this is the polymer chain. Okay, this is the polymer chain of polyethylene. Okay, now what we can do is we can draw the structural formula of this polymer. Okay, so somebody asks you what is the structural formula of this polymer. Okay, so what we need to do is we need to identify what is repeated. Okay, so what is repeated is 2 carbon units. Okay, you can talk about these 2 repeated over and over. So we always use 2 carbons because we need to draw a double bond at some point. Okay, so we just draw that out. So the structural formula has the repeat unit, which is going to look like that. Okay, and that is repeated in times. Okay, and this is connected to other adjacent unit. So to indicate that, I'm going to draw bonds coming out of those carbons. Okay, and that is called the structural formula of polyethylene. And now what we need to do is we need to draw the monomer of the same thing. Okay, again, when it comes to monomer, we take what is repeated, which is just 2 carbons that has hydrogens bonded, of course. Okay, and then instead of drawing 2 bonds coming out of the 2 carbons, we draw a double bond. Okay, and that is called the monomer of this polymer. Okay, let's do another one. Okay, this time what I'm going to do is I'm going to try to go the opposite way. I'm going to start with the monomer. Okay, so let's try it with the monomer. So your monomer is, let's say, this OH. Okay, if this polymerizes, write the monomer. Okay, if this polymerizes, what would be your polymer look like, or what will be the structural formula of the polymer, and how would what would be the the molecular structure of the polymer chain? Okay, so then again, what we need to do is we know that if this is the monomer, this is going to be what is repeated over and over. Okay, so let me write that. So polymer. Okay, first of all, I'm going to come up with the polymer structural formula. Polymer structural formula. Okay, so for that, what we do is we take the monomer. Okay, so here's our monomer. Okay, by the way, I mean we can draw this like this way as well. It doesn't matter. Okay, they all mean the same thing. Okay, you have two carbons, and then one of them has two carbons, and then one of them has an OH group, hydroxyl group attached to it, and the others have carbon hydrogen bonds to fulfill the common bonding pattern. That's the idea. Now, anyway, so our monomer is this. Okay, and when we come up with the structural formula, what we do is we get rid of the double bond. Okay, we just keep a single bond, and instead we're gonna draw parentheses around it. Okay, and then we're going to write that this is repeated n times. Okay, and just to indicate that this is connected to adjacent repeat units, I'm going to draw bonds coming out of each of the carbon atoms. Okay, I do the same thing here, same thing. Okay, get rid of that double bond, keep the single bond, and then say that this is repeated n times. To indicate that this is connected to adjacent repeat units, so I'm going to draw bonds coming out of it. Okay, and then if you really want to write the entire polymer, so we can do that as well. So the polymer chain, so again, we always start with the repeat unit. Okay, so what is repeated is this part. Okay, and that is repeated over and over and over. Okay, so we can connect what is we're going to connect this with bonds. Okay, it's called the polymer chain of this is polyvinyl alcohol, by the way. This is the polymer chain of polyvinyl alcohol. We can do another one. Okay, let's do one last one. Okay, now let's do polypropylene, which is another useful polymer found in binders and folders and stuff like that. Okay, so in this we have let's start with the monomer again. So PP or polypropylene, the monomer looks like this. Okay, here's the monomer of polypropylene. Okay, or if you draw the Lewis structure, it looks like common carbon double bond, hydrogen, and then one of them has a CH3 group. Okay, now what we want to do is we want to draw the polymer of this. Okay, let's go to this is the monomer. Okay, so let's directly go to the polymer chain. The polymer chain. Okay, so in the polymer chain, what we're going to have is we're going to have these monomer. Okay, let's draw the monomers. Okay, and then what we're going to do is we're going to erase the double bond. Okay. And instead, we're going to connect them to adjacent units like that. Okay. So this is how the polymer would look like. So, and then if you want to come up with the repeat unit or the shorthand notation for the polymer structural formula, let's write that as well. The polymer structural formula. Okay, you take the repeat unit, which is this. Okay, and then you draw parentheses around it, and you say that it is repeated n times, and you're going to indicate that they are bonded to adjacent repeat units by drawing these bonds like that. All right, so I think this should cover, should give an idea about the monomers and the monomers, the polymers, and the shorthand notation or the polymer structural formula that we're going to come across when we talk about the polymers. All right, I'll see you in class. Bye, everybody.